February 20th, 1943, somewhere beyond Kasserine Pass in the Tunisian desert. German Panzer commanders stared through their periscopes at something that shattered every tactical assumption they had ever learned. 5 American Sherman tanks, scattered across broken terrain where no crew could possibly see another, were attacking with choreography so precise it seemed orchestrated by ghosts. No signal flags snapped in the desert wind. No messenger motorcycles kicked up dust between vehicles. No flares arced across the morning sky. Yet these machines moved as though controlled by a single mind, covering angles their crews couldn't observe, responding to threats they shouldn't have known existed. Inside the cramped turrets of Panzers, German commanders wrestled with their Funk 5 radio sets, desperate to warn their comrades about flanking movements. Static screamed through their headphones every time an engine revved, or a track clanked against desert rock. The amplitude modulation technology that had seemed revolutionary a decade earlier now produced nothing but noise and frustration. 10 watts of transmission power evaporated into electromagnetic chaos. Before traveling 300 meters, the Americans weren't just fighting differently. They were fighting with weapons the Germans couldn't see, couldn't hear, and couldn't understand. Invisible waves of electromagnetic energy connected every Sherman tank on that battlefield into something unprecedented in military history. Frequency modulation radios, crystal-controlled precision. 25 watts of clean power cutting through the chaos like a lighthouse beam through fog. 8,000 miles away, on assembly lines in Detroit and Chicago, American engineers and factory workers had manufactured the most decisive advantage of the Second World War. Not thicker armor, not bigger guns, not faster engines. They had built something far more powerful. They had built the ability to think and fight as one organism across distances that German technology couldn't bridge. The transformation that created this advantage began quietly on July 22, 1941, when military bureaucrats in Washington signed documents that would reshape armored warfare forever. The United States Army officially standardized the Signal Corps radio sets SCR-508, SCR-528, and SCR-538 for installation in all medium tanks. While this administrative decision attracted little attention, its consequences would prove catastrophic for Axis forces. At that precise moment, Wehrmacht panzer divisions were slicing through Soviet defenses using tactics that depended entirely on radio coordination between command vehicles. German generals celebrated the success of Blitzkrieg doctrine, never imagining that American engineers were already perfecting technology that would render their communication systems obsolete. Within 2 years, the Galvin Manufacturing Corporation, operating from facilities in Chicago that would later bear the name Motorola, had assembled a team of engineers whose work would change history. Daniel E. Noble, a visionary who recognized that frequency modulation technology could revolutionize military communications, led the conceptual development. Henryk McNusky, a brilliant radio frequency engineer, solved the seemingly impossible challenge of making sophisticated electronics function reliably inside the brutal environment of a combat vehicle. The challenges McNusky faced would have defeated lesser engineers. Tank interiors generated electromagnetic interference from dozens of sources. Engines produced electrical noise with every combustion cycle. Turret motors created interference when rotating. Track movement generated static discharge. Temperature extremes ranged from freezing nights to interiors that exceeded 140 degrees. Under desert sun, constant vibration threatened to shake loose every connection and crack every component. The solution McNusky and his team developed weighed 181 pounds and transformed warfare more completely than any weapon system in history. The SCR-508 radio installation converted every Sherman tank from an isolated fighting vehicle into a node in the world's first true battlefield network. The heart of this system was the BC-60 for transmitter, a marvel of electronic engineering that generated 25 watts of transmission power. This output exceeded the German Funk 5's capability by 2.5 times. But raw power told only part of the story. The transmitter operated across the frequency range of 20.0 to 27.9 MHz, offering 10 preset channels with crystal-controlled stability that maintained frequency accuracy within 1/100th of 1%. Crystal control represented a fundamental advantage that German engineers had failed to achieve. The oscillator crystals in American radios maintained precise frequency, regardless of temperature changes or combat vibration. German radios used variable capacitor tuning that drifted constantly, requiring frequent readjustment and often causing crews to lose contact with their units entirely. The SCR-508 installation included dual BC-603 receivers, allowing tank commanders to monitor two frequencies simultaneously. This capability proved tactically decisive in combat. A platoon leader could maintain contact with his subordinate tanks, while simultaneously listening to company command frequencies. Information flowed up and down the chain of command, without the delays that plagued German communications. The true revolution, however, lay in frequency modulation itself. Edwin Howard Armstrong had invented FM technology in the 1930s, battling corporate interests that preferred the existing amplitude modulation systems. His technology, licensed to the military, offered a fundamental advantage that no amount of German engineering could overcome: amplitude. Modulation systems encoded information by varying the strength of radio signals. Every electrical discharge, every spark plug firing, every motor starting produced amplitude variations that AM receivers interpreted as signal. German tank radios picked up this interference as deafening static that made communication impossible during movement or combat. Frequency modulation encoded information through variations in frequency rather than amplitude. Electrical interference produced amplitude variations that FM receivers simply ignored. The result was voice communication of remarkable clarity even when tanks were moving at full speed, through artillery barrages with engines roaring and weapons firing. November 8, 1942 brought the first large-scale deployment of American FM-equipped armor to combat. Operation Torch landed American forces across North Africa, bringing the 2nd Armored Division ashore near Safi and Fedala in Morocco. The tanks that rolled off landing craft carried SCR-508 radios that would soon demonstrate capabilities the Arracourt had never encountered. Erwin Rommel's legendary Arracourt represented the finest armored force Germany had produced. These veterans had fought across 2,000 miles of desert, developing tactics refined through years of combat against British forces. Their experience and tactical sophistication exceeded anything American forces could claim. Yet, they operated under communication limitations that American technology had already made obsolete. A standard German tank platoon consisted of 5 vehicles. But radio distribution within that platoon revealed a critical vulnerability. Only 1 or 2 tanks, typically the platoon leader's vehicle, and perhaps 1 other, carried full Funk 5 transceivers capable of both transmitting and receiving. The remaining 3 or 4 tanks carried only Funk 2 receivers. The implications of this limitation were profound. Most German tank crews could hear orders from their commanders, but could not respond verbally, could not report enemy positions, could not call for assistance, could not warn comrades of threats. They acknowledged orders through actions, moving or firing to indicate they had received instructions. When enemy action or mechanical failure eliminated the command tank, easily identified by its multiple antennas, the remaining vehicles lost all coordination. American tank platoons faced no such vulnerability. Every Sherman carried full transceiver capability. Any tank could assume command if leadership was eliminated. Any crew member could report enemy positions to every other tank in the unit. The destruction of one vehicle, or two, or three, did not degrade the communication capability of survivors. The Battle of Kasserine Pass, fought from February 14 through February 24, 1943, provided the first major test of American armored forces against German opposition. The tactical results were humbling. German forces under Rommel's command exploited American inexperience and achieved a significant victory that pushed American lines back 50 miles. Yet within this defeat lay evidence of capabilities that troubled German observers. Scattered elements of the 1st Armored Division, separated by terrain and enemy action, maintained coordination across remarkable distances. Tank crews who had never trained together coordinated attacks and mutual support through their FM radios. Reports flowed to headquarters with speed and accuracy that German signals intelligence officers found disturbing. The 10th Panzer Division's intelligence section compiled reports on American communication capabilities that revealed growing concern. American units maintained clear radio contact at ranges where German equipment produced only static. More alarming was the apparent conclusion that every American tank possessed full transmission capability, not merely command vehicles. German signals intelligence units intercepted American radio traffic and noted its exceptional clarity. The absence of static and interference puzzled analysts accustomed to the constant noise that plagued their own communications. Some attributed American clarity to superior discipline and procedure rather than technological advantage, a fundamental misunderstanding that would persist throughout the war. The German Funk 5 radio, operating on amplitude modulation in the 27.0 to 33.3 MHz frequency range, suffered from limitations that no tactical adjustment could overcome. The 10-watt transmitter achieved ranges of 2 to 3 kilometers under ideal conditions. But combat conditions were never ideal. Engine noise reduced effective range to hundreds of meters. Movement created interference that made communication nearly impossible. Every component of a moving tank generated electromagnetic interference. Spark plugs fired thousands of times per minute, each ignition producing electrical noise. Generators created interference as they charged batteries. Electric motors for turret traverse and gun elevation added their own contribution. Track links striking drive sprockets generated static discharge. All of this interference overwhelmed amplitude modulation receivers. September 1943 brought American armor to the Italian mainland, where mountainous terrain presented communication challenges that seemed likely to neutralize American advantages. Radio waves behave unpredictably in mountain environments, reflecting off rock faces, diffracting around ridgelines, creating dead zones and interference patterns that complicate communication. Frequency modulation technology handled these challenges far better than amplitude modulation. The SCR-508 maintained usable communication in terrain where German radios failed completely. American tank platoons coordinated movements through valleys and across ridges, where visual signaling was impossible and German communication technology would have left crews isolated. The advance toward Monte Cassino demonstrated capabilities that defied German tactical doctrine. Tank platoons separated by terrain features. Coordinated attacks with timing that German commanders insisted required visual contact. After-action reports from the 1st Armored Division described routine coordination at distances of 7 miles, while moving 10 to 15 miles when stationary. German doctrine had developed around the limitations of German technology. Planners assumed that tank units separated by terrain would lose coordination and operate independently until visual contact was restored. They designed tactics around this assumption, never imagining that enemy forces might maintain communication, regardless of terrain or visibility. June 6, 1940 marked the largest amphibious invasion in history. Sherman tanks equipped with specialized flotation devices churned through the surf toward Normandy beaches, their SCR-508 radios maintaining contact with naval fire support coordinators offshore. This capability, communication between tanks and naval vessels for fire coordination, was impossible with German technology. The hetero country of Normandy, however, revealed a critical gap in American communication planning. Tank radios operated in the 20.0 to 27.9 MHz frequency range. Infantry radios, the -300 Seychelles Rupees backpack sets carried by foot soldiers, operated in the 40.0 to 48.0 MHz range. The two systems could not communicate directly. The Norman bocage consisted of small fields surrounded by hedgerows, earthen walls topped with dense vegetation that had grown for centuries. Visibility rarely exceeded 100 meters. German infantry armed with Panzerfaust anti-tank weapons could approach American tanks through covered terrain, while American infantry with clear sight of the threat had no way to warn the tankers. This communication gap proved deadly in the weeks following the invasion. Sherman tanks burned throughout the bocage, destroyed by infantry attacks that nearby American soldiers could see, but could not report to the tank crews. The technological sophistication that connected every American tank to every other American tank had failed to connect tanks to the infantry fighting beside them. American forces developed a solution with characteristic pragmatism. Tank crews mounted E8 field telephones and ammunition boxes welded to the rear hulls of their vehicles. These telephones wired directly into the tank's internal communication system, allowing infantry following the tank to lift the handset and speak directly with the crew. By the time Operation Cobra launched on July 25, 1944, this modification had spread throughout American armored units. The simple telephone box, nicknamed the infantry phone, revolutionized tank infantry cooperation. Infantry soldiers could warn tank crews of anti-tank weapons, direct fire against specific targets, and coordinate movement through terrain where neither could succeed alone. Operation Cobra, the breakout from Normandy's hetero country, demonstrated the full potential of American communications superiority. The 2nd Armored Division, commanded by Major General Edward H. Brooks, coordinated more than 200 Sherman tanks across a fluid battlefield that changed hourly. Radio networks enabled command and control that no army had previously achieved. German defenders from the Panzer Lehr Division, once among the finest armored formations in the Wehrmacht, faced an enemy that seemed to possess impossible awareness. American tanks responded instantly to threats reported by other units miles distant. Artillery support, called through tank radios, arrived within minutes of target identification. Flanking movements materialized from directions that German defenders had believed secure. The contrast with German capabilities had become stark by the summer of 1944. Panzer Lehr, like most German armored units, had been reduced to communication poverty by attrition and production shortfalls. Most tanks operated without radios of any kind. depending entirely on visual signals in terrain, where visibility rarely exceeded 100 meters. The few functioning radios suffered from the interference and range limitations that had plagued German communications since the war's beginning. Crews struggled to hear transmissions that static rendered unintelligible. Company commanders lost contact with platoons, separated by mere hundreds of meters. The historical irony of this situation was profound. Germany had pioneered the use of radio communication in armored warfare. Heinz Guderian, the intellectual architect of Blitzkrieg doctrine, had insisted on radio equipment for tanks since the 1920s. His influential book Acting Panzer, published in 1937, emphasized communication as essential to the rapid armored operations. He envisioned Guderian had developed the tactical concepts that made radio coordination central to German armored doctrine. He understood that the speed of armored advances created situations where traditional command methods could not function. Couriers could not keep pace with tanks. Telephone lines could not be laid fast enough. Only radio could provide the instant communication that armored warfare demanded. Yet by 1943, German industrial capacity could not provide the radios that Guderian's own doctrine required. Production figures revealed the magnitude of German failure. In 1943, German factories manufactured approximately 5,700 medium tanks. They produced fewer than 2,000 Funk 5 transceivers. Many of those radios went to command vehicles, assault guns, and other priority systems, leaving regular tank units desperately short. Soviet armored forces suffered even more severe communication deficiencies. The T-34, despite being the most produced tank design in history, typically entered combat without any radio equipment. Soviet doctrine compensated by relying on pre-battle planning and flag signals, with catastrophic results when plans failed to survive contact with the enemy. The destruction of Soviet armored formations in 1941 resulted partly from this communication poverty. German forces with radio coordination annihilated Soviet tank units that could not adapt to changing battlefield conditions. Individual T-34s might possess superior armor and firepower, but they fought as isolated vehicles while German tanks fought as coordinated teams. Lend-Lease provided some relief for Soviet communication problems. American radios, including SCR-508 sets, equipped Soviet command tanks beginning in 1943. Yet even by the war's end, only approximately 25% of Soviet tanks carried radios of any kind. The remaining 75% fought essentially deaf and mute. The comparison highlighted the magnitude of American achievement. While the Soviet Union struggled to equip 1/4 of its tanks with any communication capability, America achieved 100% deployment of sophisticated frequency modulation systems. Every Sherman that left the factory carried the ability to participate in the battlefield network. The Motorola factory in Chicago represented American industrial mobilization at its most impressive. Before the war, the facility manufactured automobile, radios, consumer products that bore little resemblance to military equipment. Converting to military production required complete retooling, new quality control systems, and solutions to engineering challenges that commercial products never faced. Each SCR-508 installation required 2,748 individual components manufactured to military specifications far exceeding commercial standards. The BC-600 for transmitter alone contained 470 for capacitors and 385 resistors. Crystal oscillators had to maintain frequency stability despite temperature extremes, ranging from Arctic cold to tropical heat, and vibration levels. that would destroy commercial electronics. Production statistics documented the acceleration of American manufacturing capability. In 1942, the first year of full production, factories delivered approximately 3,800 radios of the SCR-508 family. Production nearly tripled to 11,400 units in 1943. It more than doubled again to 24,000 units in 1944. Total wartime production exceeded 50,000 tank radio installations. This production miracle ensured that all 320 for Sherman tanks manufactured during the war received sophisticated radio equipment. No other nation approached this achievement. Germany equipped perhaps 20% of its tanks with full transceivers. The Soviet Union managed perhaps 25% with any radio at all. Japan and Italy performed even worse, but the advantages of the SCR-508 extended beyond frequency modulation. The crystal-controlled frequency stability allowed tank units to preset channels before battle and maintain alignment throughout combat regardless of conditions. German radios using variable capacitor tuning required constant adjustment as components warmed and vibration-shifted tuning elements. The dual receiver configuration allowed commanders to maintain awareness across multiple levels of command. A platoon leader monitored his platoon net while simultaneously listening to company command frequencies. A company commander heard battalion instructions while maintaining contact with his platoons. Information flowed through the network with speed no other army could match. The BC-606 interphone system integrated seamlessly with the radio installation, connecting all 5 crew members in continuous communication. Any crew member who spotted a threat could instantly alert the commander. The loader scanning through his periscope could report enemy infantry. The driver could warn of terrain obstacles. The bow gunner could identify targets for the main gun. German tanks often lacked interphone systems entirely. Crew members communicated by touch signals or shouting over engine noise. A loader who spotted an enemy flanking movement had no way to alert the commander, whose attention focused elsewhere. This internal communication failure cost German crews lives that better technology might have saved. Throat microphones and noise cancelling headphones enabled clear communication during combat when engine roar and weapon fire created sound levels that would otherwise prevent any speech. German tankers often could not hear radio transmissions when their own weapons fired, creating gaps in awareness at precisely the moments when communication mattered most. Power management provided another American advantage that rarely received attention. The SCR-508 operated on either 12 or 24-volt electrical systems, automatically adjusting to available power. The dynamotor power supply provided stable, filtered power that eliminated electrical interference from the tank's electrical system. German radios connected directly to vehicle electrical systems without filtering. Every voltage fluctuation, every generator irregularity, every electrical load switching on or off produced interference that the radio reproduced as noise. This interference combined with environmental noise to make German radio communication difficult at best, impossible at worst. The tactical advantages of universal radio deployment transformed American armor doctrine in ways that German forces never fully understood. The combat command structure, which organized flexible task forces from different units for specific missions, depended entirely on reliable communications. American commanders could create ad hoc battle groups confident that units from different battalions, different regiments, even different divisions could coordinate through compatible radios. This flexibility baffled German commanders accustomed to rigid organizational structures. German doctrine assumed that units could only coordinate effectively with forces they had trained with extensively. The limited communication capability of German formations made this assumption necessary. American communications superiority made it irrelevant. The Battle of Arracourt in September 1940 demonstrated how communications superiority could overcome material disadvantages. The 4th Armored Division, part of Patton's 3rd Army, faced multiple German Panzer brigades equipped with Panther tanks. On paper, the Germans held every advantage. The Panther mounted a high-velocity, 75mm gun superior to the Sherman's weapon. Its frontal armor resisted standard American ammunition at combat ranges. Its tactical mobility matched the Shermans. Yet the Panther's technological sophistication did not extend to communications. German crews fought in the same radio poverty that afflicted all Wehrmacht armored forces. They could not coordinate effectively. They could not share information about American positions. They could not mass fires against identified threats. American radio coordination proved decisive across 3 weeks of fighting. Every Sherman reported enemy contacts instantly. Tank destroyers received targeting information from tanks they could not see. Artillery observers in command tanks called in devastating fire missions within minutes of target identification. The statistical results defied what technology comparisons would predict. The 4th Armored Division destroyed 281 German armored vehicles during the Arracourt fighting while losing only 41 Shermans, a kill ratio exceeding 7-1. The technically superior Panther died in numbers that reflected its communication inferiority, rather than its armor superiority. Throughout the war, German intelligence failed to grasp the significance of American communication advantages. Combat reports consistently mentioned American coordination, but attributed it to training and doctrine, rather than technology. A captured intelligence assessment from September 1940 concluded that American tank units demonstrated good radio discipline and coordination resulting from extensive training and rigid communication procedures. The assessment completely missed the technological dimension. German analysts could not conceive that American capabilities resulted from equipment rather than procedure because they could not imagine equipment so superior to their own. They assumed both sides operated with similar technology and attributed differences in performance to human factors. This intelligence failure prevented German tactical adaptation. German forces continued targeting supposed command tanks based on antenna configurations, not understanding that destroying any Sherman left surviving tanks with full communication capability. They planned ambushes assuming American tanks would lose coordination when separated, not realizing that radio contact maintained unit cohesion regardless of visual contact. March 1945 brought American forces to the Rhine River, the last major barrier protecting the German homeland. American communications superiority reached its peak during the race to establish bridgeheads across this historic obstacle. When elements of the 9th Armored Division discovered the Ludendorff Bridge at Remagen still standing on March 7th, radio communication demonstrated its decisive value. Reports reached 1st Army headquarters within minutes of the discovery. Confirmation and authorization flowed back down the chain of command with equal speed. Within an hour, divisions across the entire front received orders shifting to exploit this unexpected opportunity. The speed of American command and control created a tempo that German forces could not match. German defenders, dependent on telephone networks that American aircraft had systematically destroyed, could not respond with comparable speed. Reports traveled slowly up German chains of command. Orders traveled slowly back down. By the time German commanders organized counterattacks, American forces had established bridgeheads too strong to eliminate. American radio coordination created an impenetrable defense of the Remagen bridgehead. Tank platoons from different battalions integrated seamlessly, coordinating fires through radio networks without the familiarization that German doctrine considered essential. German counterattacks, poorly coordinated due to communication failures, arrived piecemeal and were destroyed in detail. April 1945 witnessed the encirclement of Army Group B in the Ruhr Industrial Region, a demonstration of American communication superiority at operational scale. Armored columns from the 1st and 9th Armies executed a complex double envelopment, coordinated entirely through radio networks. Thousands of vehicles across hundreds of miles maintained the coordination necessary for this massive maneuver. Inside the Ruhr pocket, 325,000 German soldiers found themselves trapped, partly because their communication infrastructure had collapsed. American fighter bombers, guided by radio-equipped forward air controllers, systematically destroyed German communication nodes. Wehrmacht units lost contact with higher headquarters and with adjacent formations. Command authority fragmented. Field Marshal Walter Model's final messages before communication failure revealed the German plight. In stark terms, no contact with adjacent units, no communication with higher headquarters. Fighting continues, but coordination impossible. Model, one of Germany's most capable defensive commanders, could not employ his skills without the ability to control his forces. American radio superiority profoundly affected the psychological experience of tank warfare. For crews on both sides, American tankers fought with the constant reassurance that they were never truly alone. Even when physically isolated by terrain or tactical situation, they remained connected through radio waves to comrades who could provide support, advice, or simply the comfort of human voices. German tank crews experienced profound isolation that compounded the terror of armored combat. Unable to communicate, they fought individual battles within larger engagements they could not comprehend. They could not know what was happening beyond their limited vision. They could not request help when threatened. They could not warn others of dangers they observed. Otto Carius, among Germany's most successful tank commanders, with more than 150 kills to his credit, wrote extensively about armored warfare in his memoir Tigers in the Mud. Though he focused primarily on tactical aspects, his accounts reveal the challenges that limited communications created for German crews. The strategic implications of communication superiority extended far beyond individual engagements. American advances in 1944 and 1945 maintained operational tempo, partly because radio networks sustained command and control across distances and speeds that would have fragmented German forces. The Third Army's race across France depended on communication networks that maintained coherent control of formations operating across hundreds of miles. German commanders consistently underestimated American capabilities because they could not conceive of the communication superiority Americans possessed. They planned based on assumptions derived from their own technological limitations. When American forces repeatedly exceeded those expectations, German commanders attributed the results to luck, numbers, or air superiority, rather than recognizing the true source of American advantage. Heinz Guderian, in his role as Inspector General of Armored Troops, recognized the communication problem, but lacked the resources to solve it. A December 1940 memorandum acknowledged that American coordination negated German advantages. In tank quality, Guderian understood that his own doctrine required communications that German industry could not provide. After Germany's unconditional surrender in May 1945, American technical intelligence teams conducted systematic evaluations of captured German equipment. Their findings confirmed what combat experience had demonstrated. German tanks often possessed superior armor and armament, but their communications equipment lagged years behind American systems. United States Army Technical Intelligence Report number 176 concluded that German tank communications equipment was approximately 5 years behind American development. The absence of frequency modulation, limited radio distribution, and poor electrical suppression systems created critical vulnerabilities that superior armor and armament could not overcome. Soviet technical teams reached similar conclusions when given access to captured German equipment. The Red Army, rebuilding its armored forces after the catastrophic losses of 1941, chose to copy American radio designs rather than German systems for post-war development. This decision acknowledged American superiority in the technology that Soviet leaders now recognized as decisive. A comparison of production and deployment statistics reveals the magnitude of American achievement. In quantitative terms, American factories produced more than 50,000 radios of the SCR-508 family. They manufactured 320 for Sherman tanks. The radio deployment rate achieved 100%. Every tank carried 25 watts of transmission power with crystal control. Frequency stability. German factories produced approximately 6,000 Funk 5 transceivers. They manufactured approximately 12,000 medium and heavy tanks. The full transceiver deployment rate reached only approximately 20%. Each radio provided only 10 watts of transmission power with variable frequency stability that drifted constantly. Operational effectiveness statistics told an equally dramatic story. American tank units achieved fire mission coordination in 3 to 5 minutes from target identification. German units required 15 to 30 minutes for equivalent coordination. 100% of American tanks could participate in coordination. Only 20% of German tanks possessed full communication capability. The radio superiority of Sherman tanks established principles that govern armored warfare to this day. Modern main battle tanks carry communications suites that trace their conceptual lineage directly to the SCR-508. Digital technology has replaced analog, but the fundamental principle of universal deployment and reliable coordination remains unchanged. The German Bundeswehr, rebuilt in the 1950s under American guidance, prioritized communications based explicitly on World War II lessons. Every Leopard tank manufactured has carried comprehensive radio systems. Bundeswehr training documentation explicitly states that the defeat of superior German tanks by inferior American vehicles with superior communications teaches that information dominance outweighs platform superiority. Modern conflicts have validated this lesson repeatedly. The 1991 Gulf War demonstrated coalition forces with superior communications, destroying Iraqi formations equipped with individually capable Soviet-designed tanks, but inferior radios. The 2003 Iraq War again demonstrated that network-centric warfare defeats platform-centric warfare. Information superiority trumps armor superiority. The full story of American Sherman tank radio superiority represents victory in an invisible battle space that proved more decisive than any advantage in armor or firepower. German tank crews fought their war partially blind to this revolution in military affairs. They discovered too late that every Sherman was not merely a fighting vehicle, but a node in history's first true battlefield network. The SCR-508 radio installation transformed the M for Sherman from an adequate medium tank into a component of a weapons system that included every other American tank within radio range. This transformation proved more decisive than any possible improvement in armor protection or main gun capability could have achieved. Every Sherman tank carried the tools of victory not in its 75mm main gun, not in its sloped armor, not in its reliable engine, but in the 181 pounds of radio equipment that connected its crew to every other American crew on the battlefield. This connection created collective intelligence that no individual German tank, regardless of its superiority in any measurable specification, could defeat. German forces discovered this reality through experience paid in blood at Kasserine Pass, in the mountains of Italy, across the hedgerows of France, and in the final battles on German soil. American tanks demonstrated coordination that German doctrine insisted was impossible. Without visual contact, the Wehrmacht never developed effective countermeasures. Because they never fully understood the technological gap they faced. Field Marshal Wilhelm Keitel reportedly observed at Germany's surrender that German engineers knew how to build better tanks, but American engineers knew how to make them work together. Whether this quotation is precisely accurate or apocryphal, it captured a fundamental truth about the war just concluded. America had manufactured not merely 49,320 for Sherman tanks, but 49,320 for nodes in the world's first armored battlefield network. The revolution in military affairs that contemporary analysts associate with network-centric warfare actually began in 1942 when the first Sherman tank equipped with an SCR-508 radio entered combat. From that moment, the nature of armored warfare changed permanently. The force with superior communications would defeat the force with superior platforms. The network would overcome the individual. The connected would triumph over the isolated. This transformation occurred invisible to German perception. They observed American tactical success, but failed to recognize its technological foundation. Until years too late. By the time German leadership understood that every Sherman possessed communication capabilities most German tanks lacked, the outcome of the war was no longer in doubt. The German military's failure to recognize and adapt to American communication superiority stands among the great intelligence failures of the Second World War. Despite countless engagements demonstrating American coordination advantages, German leadership never prioritized solving their critical communication weakness. They continued manufacturing superior tanks that fought as isolated individuals, while American forces manufactured adequate tanks that fought as integrated teams. The electromagnetic waves transmitted by SCR-508 radios ultimately proved more powerful than the armor-piercing projectiles fired by German 88mm guns. The capability to coordinate, to share information instantly, to fight as a unified organism rather than as a collection of individual machines. This invisible advantage determined victory more certainly than any visible superiority in armor, thickness, or gun caliber. The Sherman tank's radio superiority changed armored warfare forever, establishing the enduring principle that in modern combat, connection means survival while isolation means death. German soldiers discovered this truth across battlefields spanning 3 continents, learning through bitter experience that Americans possessed not merely numerical advantage, but technological supremacy in the dimension that ultimately mattered most, the dimension that determined the ability to fight as one.